Hey guys, and welcome back to Dan's Pro Shop. Today, got another good one for you. I know I say that a lot, but I get jazzed up about this kind of stuff. Today, I am formally announcing that Dan's Pro Shop has teamed up with Fluke Corporation. And for those of you that have been living under a rock and don't necessarily know what Fluke is, well, you should. But Fluke is like the top, the tippy top, the cream that rises above them all whenever it comes to electrical testing equipment. Now, that's not all that they provide. They have a whole cornucopia of offerings like hand tools and bags and different kinds of testing equipment and visual stuff. But their bread and butter is electrical testing equipment, and specifically multimeters. That's why we're here today. We got a fancy little item from Fluke, and we're going to go over it today, do a little review, a test, and just all around how it works. So if you're interested, stick around. We'll see how that works. So guys, like I mentioned, this is a legit partnership between myself, Dan's Pro Shop, and Fluke Corporation. It's an actual sponsorship where they're hooking me up with stuff that I can review, go over, and share with you guys. This pretty much 90% of this channel is just me going over awesome tools because I love it so much. But I have like zero moral reservations about hooking up with Fluke because they are good stuff. I mean, for lack of a better comparison, Fluke is like the Snap-on of electrical stuff. I mean, there really isn't a better option whenever it comes to meters specifically, which we're going over today. So today's video, we are going over the Fluke 323 True RMS clamp meter. Now, this is just one of the gazillion meters that they offer, but this is a good all-around, like, quick and dirty, like, first responders meter. I don't know if that's a good way to put it, but if you guys have followed me for any amount of time, you know that I am like an industrial tech. I'm a mechatronics engineer. So what I do is whenever something ain't working, I figure out why and make it work. And something like this in your tool bag can be absolutely invaluable. Now, I've gone over some Fluke stuff before, but I have not personally owned this one before. I've definitely looked at it, but I've never like owned one. And I feel like this is an awesome addition because of the variability that you can have with it. There are fork meters, there are clamp meters, there's regular DMMs, but this one is kind of like the Goldilocks. It's small and it gives you capabilities to do other stuff, specifically like wireless current testing. Now, that's not all this thing can do, but let's get into the things so you guys can actually see what it's about. So guys, like I mentioned, this is the 323. And whenever it comes to Fluke meters, they all just have like weird serial numbers that denote what they are. This particular one is a clamp meter, but it still has the probes that allow you to do like normal continuity and voltage testing. But since this thing comes apart, like some meters, the leads do not come off of the bottom. This one does. So if you need to throw something in your bag specifically just for checking amp draw, this is a nice little guy to keep with you. Let's get into the box. So right off the bat, check this out. Nice like leather case, something that's actually quality. It's not just like a little fabric pouch that's going to get tore up in your toolbox. This thing will last for as long as you have the meter. We get into here. Here's the old girl herself. And look at this. It's not that big. And that's part of the beauty of this thing is that it's small, sleek, and compact. And whenever I talk about a clamp meter, in case you guys are unfamiliar, that's what this means. So you have the ability to put a live conductor through this area here, and you can measure the current running through that conductor wirelessly. Traditionally, in order to check current, you would need to open the circuit and take the leads coming out of your meter and put your meter in series with that circuit in order to get a current reading. With clamp meters, you don't need to do that. These jaws here have coils in them that measure the magnetic field around a conductor when it's running, and it converts that energy into a unit that we can actually see, read, and diagnose electrical circuits with. Keeping on digging in the kit here, like I mentioned, this guy comes with leads to use it as a normal, regular DMM. They just plug into the bottom here, common and hot, black and red, just like almost every other one that you run across. You just plug in the regular banana connectors here, and we even have a hold function. This is pretty standard on most multimeters today, but if you're doing some kind of measurement where you probably can't see the meter, you touch your leads to whatever you're measuring, and then you hit this hold button, and then that will lock the reading that's on the screen. So whenever you're done doing your testing or whatever, you can go back to the meter and whatever you read will still be displayed on the screen. So here on the face is everything that you would expect for a basic first responder DMM. This is definitely not anywhere near the fanciest that they have. This is just good, down and dirty. I need measurements to see what's going on. We have voltage AC, voltage DC, continuity with a tone generator, and amperage AC. Down and dirty, what you need. Let's plug in the probes and see what's going on. So down here, nothing crazy. We got our common, our volts and ohms. Let's just do a little beepy beep to make sure that everything's running. You guys getting that noise there? That's that nice little reassurance that everything is operating properly. I don't need to tell you guys how valuable a continuity test is for troubleshooting in the field. For doing something as simple as checking fuses to make sure that they're good or not, or even something more complicated for checking windings in a motor. This is good stuff. It's down and dirty, and it's just great to have at your disposal along with this giant clamp meter so we can fit big conductors in here. So in case you guys are wondering about some specs on this little guy, now this doesn't do everything, but it does a lot for, like I mentioned, the first responder diagnostic stuff. This guy does wireless amperage readings up to 400 amps AC. This does not do DC, but it does do AC. Whenever it comes to voltage testing that would require you to use the leads, it's rated up to 600 volts AC and DC. The Fluke 323 clamp meter is advertised to be within 2% of absolute accuracy. That is not the best thing that's available, but like I mentioned, this guy is good for all around stuff. This isn't like the end all be all. I absolutely need to know millivolts. This is really good for down and dirty field stuff. Now on the back of the box here, it displays a couple of its cousins. What we have here is the 323. There's also a 324 and a 325. And these ones all have different functionality. Like I mentioned, this one can only wirelessly do AC current. But if you take note here, the 325, its oldest cousin, has the capability to do up to 400 amps AC or DC. So it depends on what you're looking for and what you need to do your job or your task. But I know I sound like a broken record. This guy is awesome to throw in your box just to have. And this is, dare I say, the more cost effective of the three options there. But for down and dirty stuff, this is really good. Let's just go throw this thing on some conductors and see what we get. Now, guys, just in case the safety police are out in force on this one, this is one of those do as I say, not as I do situations. Hence the disclaimer at the beginning of the video. You know, this is for educational / entertainment purposes, but you get what I'm getting at here. What the goal for this test is here, like I mentioned, down and dirty. I'm an industrial tech. Let's just say that the lathe is acting weird, okay? And we have a 3-phase 480 volt motor running this thing from this 30 amp disconnect right here. So in case you guys are unfamiliar with 3-phase, you have 3 incoming lines that they all have gigawatts on them. Great Scott. And that's what runs your prime mover and whatever it's going to. Now, the cool thing about this and what I think is like the best thing for this meter. Like, it's awesome that it does voltage and continuity and everything, and you have that ability to do it. But the sleek, small size of this thing and the fact that I can measure current wirelessly without disrupting a running circuit, because that's another thing. In order to read current, your circuit has to be live, it has to be running, it has to be doing work, it has to have a load. Something has to be happening in order for you to get an amperage reading. Voltage, you can read whether something's running or not. You simply just need to have the power source on. But that's where the caveat comes in with taking an amperage reading. Something has to be happening. So it is inherently, dare I say, dangerous to do a current test, because whatever you're doing has to be energized. But that's where like the professional aspect of this comes into it. I know it's not ideal, because like the lockout tagout thing, anytime you're working on something, you need to turn it off and de-energize. However, the world of diagnostics is kind of its own thing. Because if you have some situation like this with a weird motor that's doing something, like you feel like it's losing a leg, or like a phase is going to ground, or like you need to compare and contrast live conductors while something is operating. You need to be able to have that mentality and that mindset to know in the background this thing is running, it's hot, it's energized, and my meat hooks are in here. So just please, discretion, do this properly if you do this, especially whenever you're doing higher voltage stuff. Like, anything can be dangerous. I mean, the 115, the 120 at your house can be dangerous, but whenever you get up to 240, 480, 600, 1000 volts, I mean, it doesn't take long for you to regret that decision of making the wrong decision. So now that my little disclaimer is out of the way here, we are going to crack into this box right here with it energized, so we can run the lathe and monitor the 3 phases that are going to the motor on this thing. And we can see how balanced the load is. That's another thing that kind of like digs into the electrical theory behind 3-phase. And that's another reason why 3-phase does not require a neutral like regular single phase wiring. That's not the purpose of this video, but those of you that get it know what I'm talking about. So having a balanced 3-phase load is important, and knowing how to do this test can help you find problems before they become problems. So either way, let's just get into this. Alrighty guys, here we are at the disconnect. It is live, it is hot, she's cooking, she's ready to go, and this is what controls the lathe here. And there's like an auxiliary plug for like doing different testing of equipment and everything. So we are at the point where you need to be on your toes. This is probably the most crucial part of safety of this entire thing. I know I keep preaching this, and I may not be the best example of safety here, but this is a real world application. Let's say you're a mechanic or a technician or something at a mill. A machine is broke, something's down, production's losing time, everyone's losing their mind, second shift's coming up. You need to figure out what's going on with that thing, and you need to get it going now, because that's your job and you can handle it. So the way that I would go about this, let's just say that the lathe isn't working. I need to get into this disconnect and first of all, check that I have voltage on my line. Line is different from load. In case you guys are unfamiliar with electrical terminology, line means the power coming from the distribution location. In this case, the panel in the electrical room clean over yonder. Those are the wires coming into the top of this disconnect. The load comes out of the bottom below the switching mechanism, and that's what goes out to your actual load, where the electricity gets used and sent back into the grid. Either way, like I mentioned, that's kind of digging deep into electrical theory. But the way that I would approach this, if the lathe isn't working, I come over here, open this disconnect, and the very first thing I would do is grab my meter and set it to volts AC, because I know that this disconnect is supposed to be 480 volts, 277 per leg. That means like from leg to ground. From phase to ground should be 277, and from phase to phase should be 480 volts AC. So I set my meter at volts AC. Put that up somewhere that I can see it. That's another awesome use for clamp meters here. And then we take our probes that are now put in the bottom of the meter, and I check from phase to phase to make sure that I have juice here at this box. All right, I moved you guys up out of the road a little bit so you can see around my fat head. What we need to do here is check from one phase to the other. Can you guys see that on my meter there? 498. That's great. That means from phase to phase, I have power. And then 496 from line 1 to line 3. Line 2 to line 3, 495. So that's good. We've confirmed that our line voltage is there. So the lathe not working isn't a lack of power problem. It means more often than not, I have a problem with the load. I mean, it could be the disconnect also, but since we have this thing live and turned on, we can check the load side coming out. So we do the exact same test here on the bottom. Phase 1 to phase 2, 498, 1 to 3, 496, and 2 to 3, 495. Now, I mentioned another thing you can do to check three-phase is from phase to ground. So let's do phase 3 to ground. We have 283, 84-ish. Phase 2, 285, and 288. Now, I mentioned earlier that you should expect to see at least 277 from phase to ground. You know, here, this is an industrial environment. We're kind of jacked up. Either way, this isn't a bad thing. We have what we need here, and this is good to keep testing. Now that we've confirmed that we have voltage at this disconnect, we are getting into the meat and potatoes of this process. We are going to wirelessly check current in these three conductors. So we set our dial here up to amps, simply select a conductor that you want to measure, put it around there. You see here how we have nothing? There's 0 on the meter right now. That's because the lathe isn't running. You won't measure current on a conductor that isn't flowing electricity. Now, let's kick the lathe on, and you guys will see this thing immediately change. Now, keep an eye on the screen of the meter here. We're going to go ahead and flick the lathe on. There you go. We get 7.5, 8 amps on phase 3. Now, I mentioned earlier about having balanced phases. That means that all 3 of these legs should be, in a perfect world, less than 10% different from each other. I mean, ideally, you want them to be exactly the same. But yeah, chances of you getting all 3 of these legs exactly the same are slim to none. So really, if you see it within an amp of each other, that's really good. So let's say that we're questioning the health of the motor on the lathe. I can go ahead and check all 3 of these phases. There you go. 8.9, 8.3, 8.1. So we are within 1 amp on all 3 phases. That's telling me that the motor on the lathe is pretty healthy. It's efficient. It's doing what it's supposed to. Now, because of Ohm's law, hold on, let me shut this noisy thing off. Because of Ohm's law and the relationship between resistance, voltage, and amperage, things change whenever stuff starts to go bad. That's why this test is so important. Alrighty, now that we are all cleaned up, finished, closed up, and safe over there, let's review what just happened, because this is a totally normal, typical test that I and millions of other people do all the time, every day. This is a good, solid first responder's way to check the health of an electric motor. And I feel that 3-phase is a perfect example of this, checking that balance between the phases. So if you guys are familiar with Ohm's law, the relationship between resistance, volts, and amperage, they all affect each other. So this particular thing, we were looking for what we call a phase to ground short. I mean, not necessarily a short, because you're popping breakers and fuses if you have a direct short because the current goes through the roof, but we'll get to that. So if you're unfamiliar with the construction of an electric motor, there is a field frame with windings inside of that. So in this case, we are monitoring 3 lines into that motor that go to these big coils that create a magnetic field that cause the rotor to spin, and that's how you get rotational kinetic energy out of an electric motor. Now, whenever motors start getting old or a bearing goes out or you just overheat it for some way or whatever, something's going wrong with that motor and we suspect it being bad. Whenever we checked that line amperage in the disconnect, let's just say that line 1 was 8.5, line 2 was 8.6, and line 3 was 17. That tells me right there that I am on the verge of a phase to ground fault with that motor. Now, let me dive a little bit deeper into what that means. So because of the relationship of Ohm's law, whenever resistance goes down, amperage goes up. They are inversely proportional. So one goes up, one goes down, vice versa. So whenever we have a winding or something inside of that motor, it starts to break down, or if you get it really hot, that varnish in between the coils, it literally melts. And those of you that have smoked a motor, that's an unforgettable stink. So now we have a condition where one of those phases are starting to short to ground. It's putting its potential energy, its work, its load into the ground instead of what it's supposed to be doing. And we can monitor that by measuring current on the load inside the disconnect. I never even touched the motor. Let's just say that this motor is 6 miles away from me. I can't even see it. I don't even know what it's doing. But by doing this test right here at the source, I know how healthy that motor is because we can check the relationship between resistance and amperage, and I can check my incoming line voltage right here. And having something like this Fluke 323 that I can wirelessly check amperage on all 3 legs. I mean, you can wrap this thing around anything. Look at the size of this clamp. I mean, you can put 2 or 3 fingers in here. This thing will fit a huge conductor. And that's just another bonus of this thing, that you are not really limited about what and where you can test. So like I mentioned about that phase to ground short condition thing that we were checking for, let me put this in a little more easy to understand, I guess, in case you're not in the electrical realm here. I'm sure that you guys have experienced popped breakers at your house where you have to go flick them, reset them, and turn them back on. Well, usually you have one of 2 things happen that makes that happen. Either you have a dead short, meaning that your line goes to ground. So the resistance is now 0 and the amperage whoop, goes through the roof. So let's just say that that breaker is a 15 amp breaker. Whenever you put the juice, the black wire, to ground, now that is just a direct short, a direct path from power to ground. And the amperage, it's infinite. So that breaker pops because it cannot handle that amount of current going through the conductor. Another way that this happens is you just simply overloaded the circuit. Let's say you got like 6 space heaters plugged into one power strip off of one outlet. You are asking a lot of demand out of one little thing. And we may be rambling here, but the whole point of a fuse or a breaker is to protect the conductor, the wire itself, the stuff coming from the fuse block to the outlet in your living room. Because if there is not a limiting device at the source, that conductor will just keep going and going and going until it can't handle it anymore. That wire will be glowing red inside the wall because it is trying to provide what you are asking for. We need to have something at the source that tells it, nah. Now, you're a 12 gauge wire, dude. I am not giving you anything more than 15 amps. That's absolutely it. And even if we do hit that 15, I'm only going to give it to you for 2 milliseconds and that's it. We got to shut down, cool off, and start over again because I'm protecting your house. So yeah, most people don't know that limiting devices protect the conductor, not necessarily the thing that you're plugging into it. That's the whole point of that. Now, I know that was a bit of a sidebar, but that ties in with the phase to ground fault condition thing here that we're looking for because of Ohm's law, the relationship between resistance and amperage, the whole point of this test. I promise you, this is going full circle. But whenever you do anything electrical, knowing Ohm's law is absolutely paramount. I'm sorry. I know I got on a bit of a rant there, but if you can tell, I'm passionate about this stuff. This is what I do. It's good stuff to know. And whenever you do stuff like this, do. Oh, okay. Sorry, I've composed myself. Sorry, I'm a dad. Dumb stuff like that is funny. But now that we've gone over what I feel like to be the most valuable part of this Fluke 323, let's come back in and just, review what we've learned. So, guys, sorry about going off there, but doing tests is all fine and dandy, but you need to understand the point of the test. If you don't get the theory and everything behind it, what's the point? You're just looking at numbers. You need to know what they mean and why you're doing what you're doing. But the whole point here, the review, the look at the Fluke 323, is that this guy is so darn convenient. It's the size of your hand. It does everything you want it to do. It's got volts, it's got ohms, it's got current, it's got continuity. You get a nice little beep whenever you're checking fuses and stuff. But what I feel like to be the strong point here is, as crappy as it sounds to say, it's the brand. And whenever you're dealing with 480 volts plus, having something quality between you and that thing means the difference between you making it home or not. That's the quality of a Fluke is absolutely undeniable. It's unquestioned. There's a reason that they have been the top of the game for multimeters for so long. Like, I believe, don't quote me on this, but I'm pretty sure that the United States military only uses Fluke multimeters. I don't know if that's like an agreement thing or just the fact that they respect quality and they know what they want. But man, we're in good company because this is the absolute best stuff that you can get. Now, keep in mind, this is just one of a gazillion, like we talked about earlier, but this is a really good throw in your bag, ready to go meter because this does so much more than just a regular multimeter. Now, you may not be able to go down into millivolts and stuff, and like this is for crude field testing. If you're measuring down to the millivolt, this guy is not for you. But if you are the guy, filling a backpack full of tools and screwdrivers and stuff and going up on the roof to check a condenser fan and you need to know what's going on, this is your huckleberry. So I just want to give a huge thanks and a huge shout out to Fluke Corporation for hooking me up with this. And, here's to our prolonged partnership. You guys stick around because there's a lot more awesome Fluke stuff coming around. And I'm excited to share it with you because obviously I'm passionate about this crap. And I love talking to you guys about this stuff and getting your feedback, other people in the industry, what they do, how they would do things, yada, yada, yada. And like I mentioned, this may not be a perfect real world example, but it is a decent example of a real world situation that you might run into. And it's a perfect example of where a handy dandy little pocket sized clamp meter could come in handy. I absolutely love this Fluke 323, and I know you could too. If you're interested, check out the link down in the description, grab one of these things for yourself. If you have one in your bag, you will not regret it. I promise you. So hopefully you guys enjoyed this little review / whatever we did here today, and we will see you next time.